Hey everyone, my name is Steve Bishop and I will be your instructor for this workshop. And today we're going to be talking about interfaces in C#. So interfaces are a really nice mechanism that we have that is it's in an area of development we call abstraction. Okay, and abstraction is a really nice concept. It's actually one of the pillars of object-oriented programming. It's one of the ideals that we want to achieve with our code. We want to be as abstract with our we want to have abstract things that our concrete implementations are utilizing. And you'll see kind of a little bit of what I'm talking about there as I go through. But interfaces offer up this way of basically designing what a class should contain. What are the members, what are the methods, the properties that should be on a C# class. And then we implement that interface in an actual concrete instance of a class. And then we can build multiple different kinds of classes that all implement the same interface, and then they become interchangeable, which is really the benefit of interfaces. And hopefully I get to show you how you can move back and forth between classes doing this. So let's go ahead and start off by, I'm going to switch over to my workstation here. And I'm in my projects folder. Now I'm gonna go ahead and create a new console application. So I'm gonna do make directory, let's call this, let's say .NET workshop. Today is the 06/01/2018. All right, we'll just change over directories into that. So .NET workshop 06/01/2018. And just make sure, yep, nothing's in there. Okay, so we're gonna go ahead and make a new application. We're gonna do a .NET new, and we're gonna do a new console application. Now, I'm just gonna backtrack out here. Just for those of you who don't know that you can do this, you can just do .NET new, and it will give you the entire library of templates that you can use, and we use the short name to create one. So I'm gonna do .NET new console, but we have a whole bunch of different ones in here. We've got console, a class library, we can do some unit testing, we can make a Razor page application or a view imports page for an MVC application. We have ASP.NET Core empty, so if you wanted to start with a blank empty web application or an MVC application, etc. So we could go on down the line, but we're just going to do a console. Oops, I need to do .NET new console. There we go. All right, so .NET new console is going to construct a brand new console application for me. It's going to bring in what we call meta packages from NuGet. And meta packages are basically one big package that incorporates all sorts of little packages. So we only have to bring in one package, but it'll bring all its little package buddies along with it when we implement it. So, okay, so now we got this. Now if I do a dir, we can see that we've got our CS proj file, our program.cs file, and an OBJ folder. I'm gonna go ahead and do a .NET restore, just in case. And that .NET restore command basically inspects the CS proj file and makes sure that all of the NuGet packages that are necessary for the project have been downloaded and installed. I was pretty sure that they were, but I just wanted to show you the command. So I'm gonna go ahead and open up this project now just by doing code period, and this will open up another code window for me, which is perfectly fine to have more than one code window open. But now I'm in my project, and from here, I'm gonna open up my program.cs file. All right, now it's just a main file. We can go ahead and get rid of that. And let's see, just bring over that because I wanna get that out of the way. That was another screen I wanted to get away from. Okay, so let's take a, okay, so here we've got a question from VS Code. Required assets to build and debug are missing from yes. Let's go ahead and say yes. And that's going to actually create this VS Code folder. And we should also have now a bin and an OBJ file, or OBJ folders. And that means we've pretty much got all of the different pieces of content that are necessary in order to run this application. And if we just, if I just backtrack out that console.writeline line, I can once again just open up the command prompt here, and I could just do a .NET run, and everything's basically already downloaded and restored, and everything's good to go, so we get our hello world. All right, so we've got our blank console application that we've got all done. I'm gonna back out that console.writeline though, because we're gonna do something else. I'm going to create a interface. Okay, I'm going to create an interface. So I'm just going to go up here to, I'm going to right click. I was originally going to click on that button, but I'm going to actually do this. In case you're wondering, so I've got this little context menu. It says new C# class, new C# interface, new file. If you're wondering how I got these options, it's because I have a special extension installed in my Visual Studio Code editor called C# extensions. And it's by Jay Channon. This is one of the most useful extensions you can get. Without it, you wouldn't get that context menu. So just out here in the open area, underneath the main part of my application, I'm just gonna right click and I'm gonna say new C# interface. Now I just need to give this thing a name. I'm gonna call it IEquatable. I don't need to worry about temple files. Okay, now what I'm gonna do is I'm gonna build this interface and I'm gonna say that it's actually going to take a generic. Now a generic is basically saying this particular interface will bring in some sort of type. Like I'm gonna have to, when I implement this interface, I also am going to utilize a special type. We'll see this actual implementation happen a little bit later, but I'm gonna say bool equals, oops, whoa, that's not what I wanted, equals. And this is gonna be a function I'm going to define on this IEquatable interface. Now, one thing you'll notice about an interface is that it does not have any actual implementation code. In other words, I'm not going in here and saying, okay, well, if obj dot this equals, 2, then it's equals, right? I'm not doing any implementation details like this. This would be what we would do on a class, not an interface. Instead, an interface just simply has what we call the signature of the method or properties. So in this case, we have the signature of a method called equals. And that equals takes in a type of object that is going to be the same type that we define when we implement the interface. And you'll see what I'm talking about here as we move along. So I've got this IEquatable of t. And now I'm going to actually make a class that implements this interface. So I'm going to go and right click again, and I'm going to say new C# class. And this time I'm going to say a car class, just a simple car. And now what I'm going to do is I'm going to say that this car class is going to implement, and I use the colon to say that this class implements. It's the same thing as using a base class, right? If we were to say that car was based upon another class like automobile, if I had an automobile class, I would say, C# extends automobile. But in this case, it's the same symbol, it's the same colon, and we say which interface it is that we are implementing. Now, what I'm implementing is IEquatable, and I need to give IEquatable a type. I need to pass along to IEquatable a type. And this has to do with generics. And oftentimes you will find interfaces and generics used in conjunction to do some really cool things. Now, in this particular case, remember it was IEquatable of t was how we defined it, right? We had IEquatable of t. And t represents a type. We're saying IEquatable interface is going to receive a type. I don't know what kind of type. It's any type. At this point, it's any type. I have no idea. But on our car, we're going to figure out a bit more of the implementation details of this. So we're going to say the class that IEquatable is going to actually pass along to, the class that we're going to pass along to the IEquatable interface is a type of car. And again, just bear with me here. You'll see how this all kind of falls in line together. And in fact, if I hover the mouse over this, you're going to see car does not implement interface member IEquatable car equals car. And what's really important is this equals car. I do not have, as of right now, any methods on my car class that implement the equals function. that I defined on IEquatable. Notice that the interface says, if you are going to implement me, you need to have an equals function that returns bool and takes in whatever t is. So when we go to our car class, what this means is that we need to actually create some sort of public function here, some sort of function that takes in a car. I'm just going to call this thing lowercase car, but that should also return a Boolean. Now you'll notice that the red squiggly went away from the IEquatable of car, and I'll just show this to you again. I'll just take this out by commenting it out real quick, and you'll see that it doesn't like IEquatable car right now because I don't implement the interface of IEquatable car with an equals car, right? That's missing. But once I finally do have that member on my class, now the red squiggly goes away, and I'm no longer out of phase with the interface. I actually have the functions in my class that the interface requires. Now, it hasn't been fully implemented yet, but the method structure, like the method signature is what we call it. And a method signature basically is the data type that gets returned and the data type that gets, so all the parameters must match, the data type that comes out of it must match, and then the name of it must match. As long as all those things match up, it's going to match the requirement of the interface. So now I worry about the implementation details. Now I have to start thinking about this. How do I implement equals? And the goal of this is to say, okay, I have a car. How can I tell if the car that I have is equal to another car somewhere else? So if I was to give this equals function an instance of another car, can I compare to see if that other instance of car matches this current car? So to do that, I need to get some information. I'm going to create some public properties here. One of them I'm going to say make, because this is a car, so we're going to do a get. We're going to do a set. I'm just going to use the prop code snippet here, string model, and prop code snippet string year. Okay, so assuming that the make, model, and year is the same, then I would like, if I'm going to compare two cars to see if they are the same, right now my only criteria is going to be, are they the same make, same model, and same year? I could obviously add more properties to that. I could check the transmission type, I could check the color, I could check the interior type. Like I could check to see all sorts of things, but for our example, I'm just going to do make, model, and year. So now, this is where it gets a little fun. What is the actual implementation code we need that if I received a car as a parameter, what could I do to check if the values of that car match the values up here? That's a simple implementation process, actually. All we need to do is we just need to say if this dot make equals car dot make, and this dot model equals car dot model, and finally this dot year equals car dot year. And if all of those things are true, then we're going to return true. Yes, it is the same car. Now, we're still getting the red squiggly. That's because right now there's only one code path that returns any value, right? Not all code paths return a value. So this might be an error that you might see if you encounter this. I'm just going to tell you that the way to solve this is just basically look at the flow of the code. Is there a possible way that the code could go through and not have a response? And the answer is yes. What if one of those three conditions was false? What if it wasn't the same make, or it wasn't the same model, or it wasn't the same year? Then we don't really have anything returning afterwards. So I could just simply say return false. And that way, the only time that this would actually return true is if all three of those things were true. And then otherwise, if those three things are not true, then return false. Now, if I wanted to be a bit more expressive about it, you might have seen some code written like this to be more deliberate about, hey, it's either this or this, right? So you might see some code written that way to be very explicit. If this, return true, else return false. But we can really start slimming down some of this code, and this is just a good thing to keep in mind. There's a lot of stuff in here that's really unnecessary, and so sometimes you'll see code written in not such a verbose way, okay? Not such a expanded upon way with all these if-else statements. This is a lot of extra lines to do something that's actually quite simple. So I could get rid of the else statement, and if you follow the logic behind that, essentially a return statement is going to return out of the function. So if all those three things are true, then we're going to return out of the function true. We're going to return the value of true, but because we're using the return keyword, we're exiting out of the function entirely, and therefore this line of code would never get ran. But however, if any of these conditions are false, then this is the code that will be ran. Now you may be thinking, okay, great. So we slimmed down some code. Great, that probably is all we have to do, right? That's all the slimming down that we need to do. Well, I'm going to tell you that there's an even slimmer way to do this. If I get rid of the if statement altogether, because ultimately all I'm trying to return back is a true or false, right? Are these conditions true, or are any of these conditions false? And by saying that, I'm really kind of telling you that the result of these expressions themselves, the result of this complete expression with all of these double ampersands and all of these equals operators, all of them together return a true or false statement, because the if operator operates on a true or false premise. If this is true, then do the code. Otherwise, do false. So we already have a true or false being returned by the expression itself. The expression returns true or false. I don't need any of this other extra code around it of the if or the else statement. I don't need the return statements either. I can just do a single return statement that returns, the result of the expression. And that's it. I don't need an if or an else statement. I can just say return whatever the result of this expression is, and it'll do it. I don't need to go any further than that. I had a little extra parenthesis there. So cool, right? Like this really slims down the code quite a bit. Well, there's also one other way we can slim it down a little bit, and this is a more modern thing in the C#6 language, and that's what we call expression-bodied members. I don't even technically need the parentheses if all I'm returning is a single result. So this is an even slimmer version of everything. So I just wanted to show you, like I kind of wanted to go through that flow of how sometimes you'll see code written very verbosely by certain developers, but you might see code that's written just like this in something called an expression-bodied member, okay? So I just kind of wanted to let you in on this little secret of some different ways that developers might write the same exact thing in the same way that code's going to work. It's really up to you however you want to write it. I suggest the more verbose way to start out with, the one where you're doing the full if and else statements, all of it together. But that's all a side note. Let's get back into interfaces, shall we? So we've got this interface we've got an implementation of the interface. We've got our equals function. We know that our equals function is going to return the result of this expression of this make equals car make, and this model equals car model, and this year equals car year. So now all I need to do in order to actually test this out would be to actually run some code against it, right? So I'm going to go up here to my program, and let's write a few cars together. So I'm going to make a new car. Let's do a car class. Oops. yeah, car, we'll call it, yeah, CAR, new car. Actually, we'll do car Mazda. How's that? And we're going to say it is a new instance of a car. And we're going to set some initial values here for our car. So we're going to say the make is obviously Mazda. The model is going to be, let's do a CX-5. And the year is going to be, what did we set it as string, didn't we? I think we set it as string. Yes, we did. So we'll make it a string. So that's going to be 2013. Oops, 13. There we go. Okay, so there is our first car. Now let's make another car. Car Honda. New car. This one's going to be a make is equal to Honda. And model is going to be a Civic. And let's make this an older car. So we'll do a year. Oops. Let's make it a really old one. We're going to go really old as a relative term. Let's go with a 1993. So we got a 20-year gap between these cars. Now, I've got two cars. I got one called Mazda, one called Honda. Now, remember that on my car class, I implemented an equals function, which was really just implementing the IEquatable of car. And now I can say, okay, console.writeLine equality of cars. And we could just do this. So I need to run this function. Actually, before I get into the console.writeLine, let me just do this. Just to make things a little bit more expressive here for you guys to catch on to. I'm going to create a variable here, and I'm going to just say Boolean result, or no, we'll say equals. And we're going to say this is going to be the equals of, is the Mazda car equal to the Honda car? And then we're just going to say equals in our console window. So if these two things are equal, then we're going to write to the console window equality of cars true. But if they are not equals, then it should say equality of cars false. And of course, we would expect that it's going to say false, right? So equality of cars is false. Now, if I was to say, copy all of this, put it in here, even though obviously those are not the make of a Honda. My variable name doesn't really care. My variable doesn't actually matter. It's just a container. It's a wrapper for all this other information about a car. But now that the make, model, and year match the same make, model, and year of my Mazda, this should then be true. Now, none of that should really be surprising. But what we're going to run into is I need to find a way to make it so that I have more than one way to figure out if two things are the same. So let's say instead of IEquatable, that's a very simple example. Let me add another one here. I'm going to add another interface here, and I'm going to call this one IAutomobile. And this one, since all of our cars match make, model, and year, I'm just going to go ahead and make those the members that I need for an automobile, right? Because all automobiles pretty much need these things. So I'm just going to make those my three members of an interface. Now, an interface doesn't actually have the public on each one of the members. Notice that I'm using public to define the interface, but I don't use public then for each one of the members. So there's a little difference here between classes and these interfaces. The declaration of whether or not these are public members is defined by whether or not your interface is public. So I'm going to take off the public for each one of these members here. And we're all set, right? We're all set with that. So now I've got this IEautomobile. And what I'm going to do is, for my car class, I'm going to add that this car is not only do I need to have an implementation of IEquatable, but it needs to also implement IEautomobile. And this is perfectly fine because my car class does have those 3 properties on it. That's perfectly fine. If I tried to take off any of these, so again, if I just go and, comment out, well, I'll just comment out one of these, just for example. Notice that IEautomobile complains now because car does not implement the interface member of make because I just commented it out. All right, so we put make back in. Now, what if I have a truck? What if I have a truck? But I don't want to have equatable for truck. I don't want to have equatable for truck. So on my truck class, my truck is going to implement that IEautomobile. But that's all it's going to implement. It's not going to implement the IEquatable. So let's go ahead and put those same 3, and I'm just going to copy the code here because it makes it easy. Make, model, and year. Just copy those over. We're going to say, okay, so truck implements these 3 properties, and that's it. So we satisfied the IEautomobile implementation of having a make, model, and year. Now here's where things get a little interesting. Because if I wanted to take my program here, and I want to actually make this a truck, how would I do the comparison now? Things are a little tougher now, aren't they? How would I run the comparison between this truck and this car? Even though the values are the same, I'm going to get an error when I try to run this. We get false. We're getting false. So part of the reason why is because the equals function on my car class takes a type of car. It doesn't take a type of truck. So even though the values are the same, I'm not really getting a proper comparison. Something is wrong. And the interface is the solution here. Since both my car and my truck both implement the IEautomobile, what I can say is, well, the equals function of my car class, if I change this to IEautomobile, then I can have a proper comparison, because what we're doing here is we're saying whatever I pass into this equals function, it needs to have the make, model, and year properties on it, which we know are properties for all IEautomobiles, right? IEautomobile has a make, model, and year. So this is basically designed, this is what we call a contract. We're saying that this parameter of car is going to have make, model, and year. We know it will, whether it's a car or whether it's a truck. So this equals function will still operate. But now we have a little hiccup here because IEquatable of car is trying to say, wait a minute, you're not passing into me a car anymore. I'm expecting for IEquatable a data type that on the equals function will be the same as what I put up there. And obviously, if we look back here in car, we don't have that. We have IEquatable car, but what we're passing in is not a car, it's IEautomobile. And the answer is, well, it's a good thing we made this generic because all I have to do is change car to IEautomobile and everything's solved. Now my IEquatable interface is satisfied that I'm going to pass in some sort of IEautomobile, and this equals function expects an IEautomobile. And my IEautomobile implements those same three members, make, model, and year. And so when my program runs, now instead of receiving on my equals function, it's going to receive a truck, but a truck matches a truck since it implements, right, the truck class, we look at it again, it implements IEautomobile. And since both car implements IEautomobile and truck implements IEautomobile, we know that both of these classes can compare the make, model, and year. And since truck implements IEautomobile, it will match the requirement here of the parameter that gets passed into the equals function.
Steve, I have a quick question.
Yeah.
If IEautomobile was a class instead of an interface, would it have the same effect, or?
So if I was to change IEautomobile to a class, so the difference there would be you could do it, but then you're not really, you're basing it on a base class instead of an abstraction, which makes things a little bit more difficult to pull apart. You could do the same thing with a base class, yes. You could, because interfaces are really kind of like a way of saying, here's this base class, but instead of defining the actual implementation of it, we're just going to define what the members need to be. Okay?
Gotcha.
Does that answer your question?
Yeah.
Awesome. So as you may have noticed, when I run my function again, now I get a equality of cars is true. So all I had to do was implement the interface for both car and truck and then change around on my car class that it's going to receive IEautomobile, and then the IEquatable received an IEautomobile as the data type, as the type parameter for the class. And that solved the problem. And just again to recap here on the IEquatable, and this is probably the magic of generics, is that I could pass in any data type here as the data type for my IEquatable interface, and whatever I pass in as that type parameter will be used as the type parameter, or as the type that is required in the function, you know, right, as the method call there. Okay, so that's just really kind of really cool stuff. I think that's a good demonstration of how interfaces can be helpful, because then you can have two different classes that operate and behave in two completely different ways, but you can have some crossover functionality. You can have some similar functions among the two of them and just kind of like do this really cool stuff to swap things out, right? And then I could add a third one in here that would be another car, and it would behave exactly the same way, right? As a matter of fact, one of the other things, and I'm going to end on this, is that I don't need to say that it's a type of car or truck. I could just simply say IEautomobile, and my auto is equal to a new, and I could do either truck, oops, I could do either a new truck oops. And now you can see I could do either a new truck, and that works perfectly fine because truck implements IEautomobile, so I can assign a new instance of a truck to my auto, and I can pass in my auto here. And nothing's going to complain. The compiler doesn't care, because as long as the equals function on my car is receiving an instance of IEautomobile, it doesn't matter if it's car, a truck, or even on my variable itself is defined as a type IEautomobile. And then I can say iTruck, and that works, or I could say iCar, and that works. Doesn't really matter. So this is really cool. Like, this is some awesome stuff. Now, one thing I do want to point out, though, before I should probably wrap this up, is that since I said that my auto is a type of IAutomobile, you'll see that, remember, my car function has the equals function on it. Let's see what happens, though, when we try to call it on my auto. Even though my auto is an implementation of car, you'll notice that there is no equals function. That's because the data type of my auto is IAutomobile. It's not a car. It's an IAutomobile. And IAutomobile only has a definition for those three members on it: make, model, and year. So I can get those values from a car. I can get make, I can get model, and I can get year. But as soon as I try to go get that equals, that's a whole other equals thing going on there. That's actually something to do with something that has to do with the equals function for all objects altogether. And I can just prove that by just doing a var my object equals new object. And you can see that on my object, there is always an equals function. So my object has an equals function already on it. I'm basically overwritten that for my car class. And car takes a my auto, or takes an instance of IAutomobile. All right, so that's going to wrap it up for the interfaces demonstration. I hope that it was enjoyable and helpful for you. If you have any questions, obviously you can contact us. You can always check out also our other workshops that we have recorded on Vimeo. You should find the link in the announcement section of your course. Also, don't forget, you have that in that announcement section is a lot of really useful information about how to get a hold of anybody to, try to get some help. You got the Slack help channel for full stack web. You've got the previously recorded workshops. You've got a link to get a hold of us directly in a Zoom chat. So all sorts of good stuff. Anyway, I hope to see you guys in the next video. And until then, take care.